Hi, my name is Brandon Clayton, the Algebra Guy. Thanks for tuning in again. The subject today is domain and range of linear functions. For some reason, this tends to be a challenge for some students, but I hope it becomes easier after this video. So let's jump right into it. All right, so our goal today is to determine domain and range. When I give you a graph, when you have a word problem situation, the skill is 8.2a. I'm going to start out with just kind of trying to define domain and range a little bit, and we'll get into also discrete and continuous and what that means as well. So domain and range. So what are we talking about when we say domain? When we say domain, if we're given some function, let's say that function is y equals 2x, right? That's really basic. If we're given this function, it's asking what are all the x values for that domain. So the x could be 0. And if that's 0, it makes this y value 0. If the x value is 1, it'll make this y value 2. So these will be all my domains for if I'm talking about the x values, and my range for the y values. Now, let me write that back up here again. Actually, go back. So if I had y equals 2x, domain is going to talk about my independent or input. So input is what I'm putting in, right? That's what I'm starting with. I'm putting a 1 there to get a 2, a 0 here to get a 0, a 2 here to get a 4. So this is my input right here. And the output, the outcome that I'll get, the output that I'll get will be my y, or my range. So that's the conversation. That's how you should be thinking about it when you think about domain and range. So my independent, it's also the independent because it's not affected by what happens with the output. So if you're talking about dollars and money, right? So if this is $2 an hour, so this is X representing, let's say, the number of hours, and this is your money. So which one is dependent on the other? Well, the amount of money you get is dependent on how many hours. It's not opposite. The amount of hours you make, the amount of hours you get is not dependent on how much money you get. So the first has to be the independent, or the input, also called the domain. So you'll hear this spoken of interchangeably, but they're all the same thing. And dependent is obviously what we just talked about. It depends on what happens with the input. So now let's move on to another term, discrete. Discrete is a function whose graph is represented by individual separate points on a coordinate plane. So that's what you see here. If you see a graph like this and they're asking you if it's discrete, this is what they mean. So discrete is represented that way. Here's some examples. When would I use a discrete graph? So when you're talking about items that cannot be divided in smaller units than whole numbers. So if you got a car, for instance, if you're buying a car, you're not going to buy 1.5 cars or 1.2 cars. You can only buy whole entity of cars. You can only buy integers of cars, positive integers that is, or people or books or things like that. Things that have to be represented as whole items are going to be represented as discrete. So you're not going to see a continuous line drawn through here because we cannot account for all those decimal places in between those 2 points. It's just discrete. It's just that whole item. So for what is the domain and the range of this one? So we just spoke of domain and range. What is the domain and range of this piece here? So domain for this one is going to be all my x values, right? So it'd be literally, let's draw a little bracket to show you that I'm including all my domains here, all my x values. This is all my x values, a little colon there. All right, so my x is going to be -4, -3, -2, -1, -4, -3, -2, -1, 0, 1, 2, 3, and 4. 1, 2, 3, 4. And you're thinking that's easy. Good. I hope you think that's easy because we're really just identifying every single x value. Now notice someone may be looking at this and say, why didn't you just say from -4 to 4? Well, because it's not from -4 to 4. It's only those particular entities. To suggest that it's -4, everything from -4 to 4 would suggest that it's all the numbers in between there that are included. So if we're including all the decimal places between -3.5, -3.2, 1.5. So if you say everything in between, we're including all those pieces, and that's not true. Same thing here for the range. The range is going to be all my y values. So now I'm looking at the y values here, and I go as low as -4 and high as 4 again. So it's going to be the same numbers up here for my y value. I'm just going to write these out just to be thorough here. 2, 3, and 4. All right, so that's what it would look like for domain and range of this discrete graph. What about continuous? Well, continuous is just as it sounds, right? It's continuous. It doesn't stop. There's all the items. So see the difference between those. A function whose graph is represented by a line connecting points. So that's continuous. Examples are included with money, time, and distance. Why? Because money, you can have $1, but you can have part of $1 too. You can have a half a dollar. You can have a quarter of $1. So you can represent it by whole numbers, but also those fractions in between. Now, I understand that there's a limit, right? Because for money, it's limited to the hundredths place, right? Like 1 cent. You can't go smaller than 1 cent if you're talking about US money. However, it still be represented continuous generally on the graph because we can break it down into those fractions. Time is a big one that's used because you can have an hour, a minute, and you can break that minute into smaller parts. Seconds, you can break into milliseconds. So all those little pieces are considered when you're on a continuous graph, as well as distance. So what's the domain and range of this one? So it looks exactly the same, but we're going to write it differently because I want to include all the numbers that you can write for that's included on the domain here. So I'm going to say my domain is going to be everything from -4. So let me start out. Actually, let me erase this x. Let me do it this way. I like to, the domain is going to usually be represented this way with this inequality. So I have an x in the middle, and I know the smallest number is going to be a -4. The largest number is going to be a 4 right here. And what I'm going to say is that the x can be greater than or equal to this -4. See, it's equal because we shaded it in right there. Or it can be, and look how I'm reading it. I'm reading it from x to the -4. So I'm reading it here to the left. So it says x greater than -4. And now I'm going to read it to the right. X is less than or equal to 4. So anything between -4 and 4 will be included. Same thing for your range. We can have the highest is 4, the lowest is -4. So I'm going to put my lowest on the left, my highest on the right, and I'm going to say the same thing. It can be greater than or equal to -4, less than or equal to 4. So that's how it's written differently because it's continuous or discrete. So let's do some practice problems to see if we got this. So see if you can solve this on your paper. What's the domain, range, and is it discrete or continuous? Well, the last question should be easier, right? Discrete or continuous, it's not represented by those dots or those just integers, so I know it's going to be continuous. Domain, I'm going to draw X in the middle because I notice it's stopping on the left and the right. So there's going to be some numbers on the left and right here. I also notice it's equal on both of those. So I know it's going to be equal. So what's the smallest domain? Well, my domain is represented by my X values, as I just mentioned. So my lowest X is, when I look down here, it's 1. And if I keep following that line, the biggest X I'm going to get is a 3. Notice I'm not thinking about the Y values right now, only what the domain is. So I know my X can be greater than or equal to 1, but less than or equal to 3. So everything between 1 and 3. Same thing for my Y. The lowest Y, I like to start with the lowest Y value, so I'm looking on this Y axis of this line, the furthest it's going to go down is a 0. The highest is going to go up is a 4. So my Y is going to be greater than, equal to 4, less than, equal to 4, because these both are equal. So that's how you represent domain and range. All right, now we have a discrete graph. This is pretty easy to figure out. Pause it here and see if you can answer the domain and range for this one. All right, that's going to be discrete. Now my domain is going to be all the X values here. I'm going to draw a little bracket to represent all my X's. So I see a -4, -3, -2, -1, and 0. So -4, -3, -2, -1, 0. And what about my range? Range is going to also be in integers like this. So I'm going to start with my smallest, -4, 2. See, notice it changes, -4 to -2. I almost said -3 just to go in that same order, but it's -4, -2, 0. This one has a 2, and we have a 4. So hopefully you see that all I'm doing is taking all the y values to represent my range and all the x values to represent the domain. All right, see if you can do this one by yourself. All right, so hopefully you paused it and you worked it yourself. Let's see if this is what you got. Now remember, this open circle means not equal to. So it's not equal to that point there, but equal to this point here. So how do you represent that? Well, first of all, is it continuous or discrete? This is a continuous graph. Easy to see that. Domain is, I'm gonna write an X in the middle because I noticed that it has limits on the left and right. So the smallest X value, I'm just looking right here. I'm just looking at how far to the left this thing can go, and that's -4. And if I follow this all the way here, it stops here at an X equals 2. So X can be greater than -4, but not equal to. It's less than or equal to this 2. And that's how you represent it with an inequality. What about my range? Range is the same, right? It's represented in this, not the same numbers, but the same idea. We're going to take the lowest range number right here is -3. And now if I go up high as I can, what's the range? What's the y values of 3? So the greatest was 3, the lowest is -3. -3 can be equal to, so it can be greater than or equal to this -3. See that it's bubbled in there, or closed circle. And it can be less than, I'm sorry, greater than and less than, yes, less than everything below this than 3. We're not going to say equals to because that's an open circle. All right, let's try another problem here. What about this one here? Answer this one, please. All right, so discrete and continuous again. I'm going to say this is easily continuous. My x is, my lowest x value is going to be a -4. So I'm picking up the pace a little bit because we've done this a couple of times already. And I want to show you how simple and easy this can be when you're doing the domain and range. You're really not doing any calculating. You're just understanding that domain is all the x values and range is your y's, and understanding how to write it. So I put my x in the middle, and I'm going to say my x is going to be greater than that negative and equal to, because I can see that it's circled in, it's closed circle, and less than or equal to this 3. And y, we're going to do the same thing. So same graph. What are the limits of this y? What's the range? The lowest is a -3. Why? Because I went down here and I saw a -3 for this y value, and the highest I can go is up here to this 9. So that's 9. Greater than or equal to -3, less than or equal to 9. Now, don't just get in the habit of drawing these little angles, right? So I've seen some students just start drawing angles and not really understanding. I'm going to repeat what I was saying before, that as I read this direction, its y is greater than or equal to -3 because it's open to the y. As I read this other direction, its y is less than or equal to 9. And does that make sense? Yeah, all the numbers less than 9, all the numbers greater than 3, everything in between. So make sure you're thinking through what you're doing to double check yourself and you're not just going through the motions. All right, let's do a little word problem here. What if we had something like this? Sean already had $2 in his pocket. He knows he gets $10 a week from mowing the yard. Write a graph and the equation that would calculate the total earnings after so many weeks. So let's graph this and talk about the domain and range. What's the domain for this situation? So if I were to kind of sketch this out, it's not going to be perfect, but he started at $2. Let's put a little dot here. He started at $2 and he gets $10 every week. So this is 1 week, so he gets $10. Another week he gets $10. Another week he gets $10, and you can kind of see what's going on here. Now the question becomes, is this continuous or discrete? Well, I'm drawing dots, so it looks discrete, but is it? Can he make money in between those weeks? Or does he just get 10 and then another 10? Can he make an $8 or $7 or $5? Well, according to the situation, he doesn't. He only gets increments of 10. He already started out with 2, but he gets increments of 10. So we're just going to have to keep it that way. So if I asked you for the domain, this is going to be all these numbers going on forever. we didn't put any limit on it. So how would I represent that? Let me think, because and this is going to be discrete. So if I did domain, and what I wanted to represent here is actually the numbers. So if I put a 0 here, like he didn't work at all, technically he still should get $2 according to this equation, right? 10 times 0 is 0, and that's going to equal 2. If he did 1, that'd be 10 times 1, it's going to be 12. 2, it's going to be additional 10, 22, and so on. Now this is going to go on forever because there's no limit. So normally you don't get this, but sometimes you could if you have integers that go on forever. So how you would say this is that it's going to be all positive. Let me see if I need to write this for my domain. So my domain, there's a lot of ways you can think through this, but I want you to get the concept that this is going to be all positive answers. You're not going to get any. Your domain is your, let me write this out, is already he knows $10 a week, so it's the number of weeks. So you're not going to have a negative answer, so it's going to be all positive answers. And he's not going to be half a week, it's just going to be those integers. So I would say all positive integers. So all positive. We don't want to say all integers because it includes -1, -2. So all positive integers. Sometimes you might see that written. There's the word integers written with this funny letter Z, looking kind of weird. So just look out for that. That's what they're talking about, is integers. I believe the origin of that Z is a German word actually that started with Z for integers, so that's why we use Z. So if you see that Z, all positive integers, they're just saying that it can be 1, 2, 3, 4, and so on. What about the range? How would I do the range? Well, the range is going to be 2, 12, 22. Can there be numbers in between? Not in this case. I can only include those. So how would I write this? So it can be 2. Actually, this will help me a lot, this equation. So let me see if I can include that. 2, yeah, I'll say 2 plus 10x. And you're going to have to qualify that by saying this x cannot be negatives, because my x, again, we're not talking about negatives where x's are all positive. Well, your range is not going to be negative because you're not going to lose money. You're just going to get positive. So you're going to say something where your x's are all positive. X's are all positive. And we don't have to say multiples of 10 or anything, because this equation is telling us that. So you'll see some combination that's trying to suggest that this is only going to go up by 10s each time, starting with 2. So that's a little bit more complicated, but sometimes you may see that where you'll see a comma and they're trying to explain it. The way that's easy to work it out is draw yourself a couple of points so you can see what's going on and find out which one makes the most sense. All right, let's go to our next one. Same equation, but Shirley's trying to raise money selling t-shirts. He's already sold 2 shirts and has been selling a constant rate of 10 shirts an hour. So we're actually going to have the same situation. I tried to make this a different one, but this actually ended up being the same discrete situation. So I'm not going to do anything different on this one. I'm going to probably skip this one because it's going to come out the same way. 0, 2, 1, 12, because t-shirts cannot be split up into fractions, right? So you're going to have it be discrete. You can only have 1 shirt, and $10, you can't sell half a shirt, so you're still going to have increments of 10, 2 to 12 to 22, and so forth. So it's going to be the same thing. I'm not going to rewrite that. However, this is going to be a little bit different. Tiffany's giving $25 plus $10 an hour to babysit her baby cousin. The parents said they will be gone no more than 4 hours. Describe the domain and the range for this situation. First thing that comes to my mind is wanting to draw an equation to represent this. So I know that we're going to say y. We're going to let y equal the cost or the payment she's getting, and we're going to say x is the hour. So this y is the payment she's getting. So If you wanted to think through this and kind of see what's going on, you could put 0 here for what if she works 0 hours, how much she technically gets. And then what if she 1 hour, and so on and so forth. So Tiffany's given $25 plus $10 an hour. So $10 per hour plus 25 is the equation I'm looking at. What's the domain and range of that? Well, if I can pull up a graph, you can actually sketch that and say, well, she starts at 25 and she's doing $10 every hour. So this is move over 1 hour, we go up 10. Move over another hour, we go up 10. Move over another hour, we go up 10. So you get the idea. Over 10, 10, 10. So all we're doing is starting at 25 and she's going up at $10 every hour. So can we connect those dots or not? Well, let's ask ourselves, can she work part of an hour? Can she work 1.5 hours? 2.5 hours? Yeah. And so since she can work part of an hour, we can actually connect all these dots into a straight line. So now this becomes a continuous graph that's going to go on. Now it's not going to go on forever because we learned that they're going to be gone no more than 4 hours. So they're going to be limited. So her pay is going to be limited. So her pay is going to stop. Let me change the color right here. Her pay is going to stop right here. So everything from this 4 and below. So this is the range of her payment. So she can get from 0 to 4 hours, and she can get us from 25 to 65. And now we can represent that with our graph. We can say for our x's can go from 0 to all the way to 4 hours. So greater than or equal to, less than or equal to. And we put it this way because it can be all the numbers in between 0 and 4, 1.5, 0.5. She could work 30 minutes and they decide, okay, we're going to come back. The baby's yelling too much. We can't take it. So now the range would be from the lowest is 25. And the highest, because 4 hours is the limit, would be 65. Now, I drew this graph like this. Notice how it continues to go on, because if you put this in your calculator, sure enough, you're going to get a graph that just keeps going. But you, as a smart student, have to remember the context that we said no more than 4 hours. So we're going to limit it there. All right, so this now becomes greater than or equal to, and less than or equal to 65. You could have also just plugged in 0 and solved it, and then plugged in 4 and solved it, because 4 here times 10 is 40 plus 25 is 65. So you get your minimum and maximum from doing it that way. All right, let's go to our next problem. Star. So what does it look like if you were to test this on star? Well, let's look at what has been tested in the last years on this particular skill. The total cost in dollars to buy uniforms for the players on a volleyball team can be found using this function, where U is the number of uniforms bought. If there are at least 8 players, but no more than 12 players on a volleyball team, what's the domain? So what's the domain of this function? What's the domain? And sometimes when I see that, just go ahead and write X so I don't get that confused. In this case, it's not X, right? It's going to be our independent. And that's going to be represented by either this U or the C. Which one do you think it is, the U or the C? Which one has to go first? Well, here it is right here. I hope you say U, because once you determine the number of uniforms, will determine the cost. The cost doesn't determine the number of uniforms. The cost is going to come from the number of uniforms you get. So the uniforms have to go first. That's my domain. This U is my domain, the number of uniforms. So I'm not even concerned about cost. I'm just looking at number of uniforms. So what's the smallest number of uniforms and what's the greatest number of uniforms? Well, they said at least 8 players, but no more than 12. So which is the correct answer? Well, you may have been tempted to go 0 to 12 at first when you saw 12 and realized there was uniforms, but they said at least 8. So we have to start with 8. 0 to 400 doesn't make sense anymore, because we know we're talking about players. We can't have 425.65 uniforms. 8, 9, 10, 11, 12. That's what we want to get. Everything from 8 to 12, actually just those integers. 8 uniforms, 9 uniforms, 10 uniforms, 11. We don't want to say 8, 2. You don't want to say, then they could have done that. They could have said u between, you know, they could have done this, and that would be a tempting option for some students. But you can't have decimals. You can't have pieces of a uniform. You can't include all of those numbers. So we're just going to keep it this way. So H is our correct answer here. Let's do one more. A student rode a bike from school to a recreation center. The graph shows the student's distance in miles from the recreation center after riding the bike's X number of minutes. So if you glance at the graph, what's going on? He's riding his bike towards the recreation center. Or it says distance in miles from the recreation center. So he's 9 miles away, so he's getting there. It takes him about 28 minutes to get there. What's the range? So let's think about range. Range is this part here, right? The y values. What's the total range? So it goes from as high as 9 and all the way down to here as 0. So from 9 to 0. And notice I'm just trying to restrict your attention to the y value, because it's easy to get confused and think, oh, well, I got some numbers here. What's going? No, just the range is all I want. So just my range from 0 to 9. I don't even look at the answer choices to let them confuse me. So I'm not looking at 0 to 28. No. It's not 0 to 28. 0 to 9. Yes, that sounds good. All real numbers from 0 to 9. All the real numbers are the decimals included. Yep, you can have that for distance. You can have 1.2 miles. All real numbers less than 20. Nope, not everything less than 28. And all real numbers less than or equal to 9. This seems tempting right here, but it says all numbers less than 9. It didn't give any restrictions on stopping. So this says we can keep on going. All numbers, no, it can't be negative. We have to restrict it from 9 to 0. So that's as far as it can go. So we're going to stop that at G and close it up there. What's the range? Okay, I thought that was it. We got a couple more. What's the range of the function graphed on the grid? So range. So what's the highest and the lowest? The highest is here, right? And the lowest part on this graph is right here. And that's all I'm going to focus on. It's from -3 to 4. So I'm going to cross out anything talking about x's, because we're talking about range. I'm not even going to give that any attention. So I want anything from -3 to 4. So -3, 0 and 4. No, that's just those points. But I need all those values between. So y is greater than -3, less than or equal to 4. That'll be G there. Total cost of renting a banquet hall is a function of the number of hours the hall is rented. The owner of the banquet hall charges $85 per half hour, up to a maximum of 4 hours, plus a $50 cleaning fee. What is the greatest value in the range of this equation? So the easiest way for me to think about this is to write an equation. So you should hopefully know how to write an equation given a rate. So they give you some kind of rate, $85 per half hour. Now that's kind of deceiving, because you're going to want to think in hours. So let's make that an hour. If $85 for half an hour, how much is it for 1 hour? Well, we just need to double it, right? So that's $170 per hour. So this is $170 per so many hours. But plus they have a fee, right? So the owner of the banquet charges $85, plus he has his $50 fee. So this part right here, this 170, is where a lot of students would have made a mistake. They just would have written 85x and plus 50, but it's actually per hour is what we're interested in, not half hour. So now we know we can get 4 hours. What's the greatest value if it's maximum 4 hours? So we can go from 0. So my x values can go from, let's say my x can go from 0 to 4, but that's not what we're interested in. We're interested in what's the range. So all I gotta do is put 0 here. If I put a 0 here for x, that's gonna give me 50. So let's put a y here, so you'll know this is a function. If I put a 0 here, it's 170 times 0 is just gonna be 50. We'll at least have to pay $50. And I forgot to say this, but some of you may be confusing because you're thinking in real life, look, if I don't use the thing, why am I paying $50? Well, and for the sake of the equation, we have to write it that way because it starts out at 50 even before an hour passes by. But yes, in real life, if you're not going to use it at all, you're not going to pay. But for the sake of trying to draw a linear equation that matches this, we're going to have to include that 50. All right, so as much as 4 hours. So if I put a 4 out here, it'd be 170 times 4 plus 50, and that's going to give me my range. So what's the greatest value? That's what I really want to know. What's this greatest value? So now I have to work this out. I don't want to take out my calculator, so I'm just going to do it this way. 8, 2, 4, 680. So this is my greatest. So it can be greater than equal to 50, less than equal to 680. So that's the greatest amount is 680 is the answer. I would have put it on my answer document. All right, what's the range? This should be pretty straightforward as well, because we're just going to take the highest y value and the lowest y value right here. Now be careful, because that's an open circle. So I know that before I even look at my answers, right? If I were to cover up all this, I don't want to be confused, because they throw some confusing things in there. Actually, I'm just looking at this. They said range, and I already know my x's aren't going to be a possibility. So my lowest y is a -3. My highest is a 3. And the lowest one is a closed circle. So I know it can be greater than or equal to that one. Everything greater than that, but less than this 3. That's what I'm looking for. So I'm not going to be confused now, because I got the answer in front of me. So I'm looking for greater than or equal to -3 and less than 3. And here is my answer. All right, why don't you try to work this one? This one seems pretty straightforward. Which graph shows a function with a domain? A domain, this is my x values of all real numbers greater than 7. Notice it didn't say greater than or equal to 7, just greater than. So I need an open circle, and it looks like they all do have that. So all numbers greater than. So this right here shows all numbers greater than 7 as a domain. This one shows all numbers greater than 0, right? 0 all the way down. It starts at a y of 7, but the x values are 0. This one only does 7 as the x. We want everything greater than 7, and this one only does 7 and below. All the so those aren't going to be it. This is my answer. So those don't take very long. And now this is our last question. So this was the toughest one. Most students will miss. It was a long time ago this was given. The number of ferry boats, f of c, needed to transport the number of cars in one day can be found using this function. If there are no more than 5,000, the greatest is 5,000 cars transported by ferry boat daily, what's the range of the function? So the greatest you're going to have is 5,000 cars. So if this is 5,000, let me see if I can do this by hand. What number can this be? That's the most it can be. It can be no more than that. Can it be equal to that? Yeah, it can. It didn't say it can't be. It just can't be more than 5,000. If there are no more than 5,000 cars, what is it going to be? So let's do the math here and see what's the greatest y, because this is our y and this is like our x. This is our input and this is our output. So divide by 10, those go away. Now I got 500 divided by 2, so that'll equal to 50. So the greatest number of ferry boats you're going to need is 250. So the set of all numbers, let's say, what is the range? So the smallest, there are no more than 5,000. So you can have 0 here, right? From 0 to 250. 0, put a C, since they want to do C instead of X. So if we had C, it can be from 0 to 250. So C is going to be greater than or equal to 0 or less than or equal to 250. The set of all integers from 0 to 250. There we go. And remember, integers are your 1, 2, 3. We're not doing all real numbers. The set of all integers greater than or equal to 250. We don't want numbers greater than 250. No. All integers from 0 to 5. No, definitely not. And the set of all integers greater than or equal to 5,000. No. So we want to pick D in that case. All we have to do was plug in this 5,000 to figure out what the max is, and plug in 0 to figure out the minimum. So from 0 to 250. Did we do it? My goodness. Sorry, I know it was a long video, but man, it's such a huge topic. You see how many practice problems I put on there from the start. Why? Because that is a huge topic, and too often, too many students miss that. You should be mastering that by this. Go back through the video, do the worksheets if necessary, but you should master this topic because it's so simple, domain and range. Guys, thanks for tuning in. I will see you next lesson. My name is Brandon Clayton, and take care.